Innovation thrives on our ability to creatively apply knowledge and experience to solve challenges across different fields. This means that knowledge from one area can be transferred and adapted to new and often unrelated areas, opening doors to groundbreaking solutions. This is typically known as the art of cross-pollination in innovation. Today, we are exploring an exciting concept in artificial intelligence called transfer learning, which is on its path to expediting innovation across industries. What if I told you we could apply learning using an artificial neural network with a convolutional neural network CNN to identify dog breeds to detect skin cancer in humans and vice versa? This technique is also transforming industries like healthcare and pet care alike. So let's dive into what transfer learning is all about and discover how it could help vets provide even better care for our furry friends. Transfer learning is a technique in machine learning where a model developed for one task is reused as the starting point for a different but related task. Imagine you have already trained a model to recognize breeds of dogs from thousands of images. With transfer learning, you can take the knowledge from this model and adapt it to recognize signs of dog diseases, like skin lesions or abnormal growths, without starting from scratch. It saves time and resources and gives us a head start on more complex challenges. Behind the scenes, transfer learning relies on importing mathematically trained parameters from a previously trained model into a new one. A model learns specific parameters like edges, shapes, and textures when trained. With transfer learning, we can take these learned parameters from one model, for instance, a model that identifies animals, and apply it through additional trained parameters to detect, for example, skin issues in dogs. The same trained model can detect human skin cancer with minor modifications. With a machine learning model being heavy on computing, especially with models related to large and unstructured datasets like images and videos, transfer learning presents an amazing innovation where we could use a pre-trained model and run it on a laptop for an entirely new use case. Now, let's look at a few use cases of how transfer learning can make a difference in pet care. Suppose you have a machine learning model trained to recognize typical dog breeds. This model can be fine-tuned with transfer learning to detect specific skin conditions. For example, it could identify patterns associated with mangy, hot spots, or ringworms just by analyzing the skin images of dogs, which helps vets catch these conditions early. Another use case is related to monitoring mobility in dogs. There's a lot of data on human gait analysis used in medical fields. With transfer learning, a model trained to recognize walking patterns in humans can be adapted to analyze dog mobility. Vets can use this information to detect early signs of arthritis or other joint issues by recognizing abnormal gait patterns in dogs, helping to create better treatment plans sooner. These are just a couple of examples, but the possibilities are endless. Transfer learning is opening doors for vets to improve diagnostics and treatment, all thanks to advanced AI models that learn from one domain and help out in other.